Hi, good evening, everyone. I hope my voice is clearly audible. You can simply raise your hands to confirm this. All right, great. So let's proceed ahead with the discussions, right? So today, technically, today we'll start with the technical discussions, right? We'll start with very basics, and then eventually and gradually we'll introduce more complex topics. All right. So today we are going to discuss about the basic arithmetics that is used in mathematics. All right. So let's proceed ahead. Let me just give you this overview that what we are going to discuss today. Right. So today we are going to discuss. Right. So today basically we are going to discuss about the basic arithmetics, right? And in this basic arithmetic, right, we are going to discuss about the basic operations, starting with addition, right? Moving ahead with subtraction, moving ahead with multiplication, moving on with division, right? We'll also discuss about the power function, right? Then gradually we'll move ahead discussing about the BODMAS rule, right? And we'll also discuss about the exponential functions. We'll see how percentage can be calculated, right? What percentages and how it can be calculated, right? Proceeding ahead, we'll discuss about the sum product function, right? How weighted sum can be calculated. All right, so this will be the overall agenda for today, and if time permits, we'll discuss more topics. All right, so let's proceed ahead with the discussions. And again, if you have any doubts during the session, you're free to ask your doubts in the chat section. I'll be addressing your doubts one by one. All right, and you just need to have patience after posting your doubt, right? So that it takes time to go through everyone's doubts and address each and every doubt individually. All right, so let's proceed ahead with the discussions. Right, so starting with the addition. Addition is basically when you are adding numbers, right? So basically, only I hope everyone understands that addition can only be performed on numbers, right? Although you can perform addition on with the text data as well, right? And technically, it is known as concatenation, right? And addition of numbers is nothing but the summation that we are going to take. Right. So let's discuss about the addition of numbers. It is very simple and basic. I hope everyone knows. Let's say if you want to add two numbers, right? So you can directly proceed ahead with using this plus sign between the numbers, and you'll be able to add the numbers, right? So an example could be, let's say if A is 2 and B is 3, right? So if you want to go on with performing the addition operation, right? So eventually, let's say there's some variable C which I'm assigning to the result that I'll get from A plus B. All right. So guys, I hope my voice is clearly audible. You can simply raise your hands to confirm this if my voice is clearly audible. All right. 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 So those of you who are not able to hear my voice, they can simply rejoin the session. Right. The session is being broadcasted very fine from my end. Right. And absolutely there are no audio or video related issues. Right. So moving ahead, let's say C is the variable that I'm assigning, right? A, B, and C are variables here. These are nothing but these are referred to as variables. Right. And let's say C is the output that I'll get from as an output from this particular operation, right? So 2 plus 3 will eventually land up giving us the value of C as 5. Right. So this is how addition is performed. And addition is basically right. So this is the basic operation of addition, right? And there are a few properties associated with addition. Right. I hope everyone is well aware of the properties of addition. Right. And the properties are as follows. Right. So in the first go, your addition is commutative. Right. So this basically means, let's say A plus B is equals to B plus A. Right. So this is like if you even interchange the positions of the variables, the result will be unaffected. Right. So this is the commutative property of addition. Next, we have the associative property. Right. Associative property majorly indicates that, let's say if you have three variables, right, A, B, and C, and you're performing an addition on all these variables, right? So if you, let's say, do A plus B plus C, right? So this could be in any format. Since commutative is one of the properties, so the order can be anything, right? It could be B plus C plus A, or let's say C plus B plus A, or C plus A plus B, and the order could be anything, right? Now, the thing is, let's say you can add A and B first, and then finally add C to this, and let's say Z is the output variable that I'm assigning here, right? So this is basically equals to, let's say if you add A to B plus C, or the output of B plus C, right? So for example, let's say if A is 1, B is 2, and C is 3, right? So we can easily be proven. Let's say what we'll do first is we'll add A plus B first, and then followed by adding C to this, right? So the output is 1 plus 2 is 3, so 3 plus 3 is 6, right? And if I, let's say, add B plus C first, which means 1 plus 2 plus 3, I'm going to add 2 plus 3 first, and then I'm going to add 1 to this, right? So eventually the output will again be 2 plus 3 is 5, and 5 plus 1 is 6, right? So this is basically the associative property, right? Now, next is the distributive property. So what does distributive property basically mean? Let's say if I'm multiplying a particular constant to sum of numbers, right? So let's say we have a plus b, and I'm multiplying some variable c to both of these, right? So basically, this gets distributed to each of these individual variables, which means c times a plus b is equals to ac plus bc, right? So c gets distributed in both of them equally, right? So one of the examples again could be, let's say a is 1, b is 2, and c is 3, right? So let's say if I'm multiplying 3 times 1 plus 2, right? So this gets distributed equally to both of these, which means 3 into 1 plus 3 into 2. This is how it gets distributed, and eventually the output of this is 3, and the output of this is 6, right? So 3 plus 6 is 9. This is the output, or this is the final result, right? At the same time, let's say if you multiply 3 with the addition of these numbers, right? So 3 times 1 plus 2 is 3 again. So 3 times 3 is 9 again, right? So this basically is the distributive property. It gets distributed equally. All right. Next will be additive property or additive identity. Right? Additive identity property. This basically says if you add 0 to any real number, the output will be the real number itself, right? So for example, if I add 0 to the value of a, so the value of a is 1, right? So 1 plus 0 is 1 itself. Same goes with b and c. Let's say if I add 0 to b, the output will be 0, b itself, right? So b is the real number here, a and b are the real numbers, and 0 is of course again the real number, but this is an additive identity property. All right, so this is the properties of addition, and I hope most of you are well aware of these properties, right? And just give you so that all of these are visible in one single screen. All right. So the agenda has already been discussed, guys. It is advised to everyone to join. Please join the session on time, right? Right. So distributive is not here. Distributive is basically, let's say, distributive is basically a property of addition. Any you multiply this constant with a sum of numbers, so this equally gets distributed in both of these. All right. So let's take one more example. Right. So let's say I have x times y plus z. Or let's take one more number. Let's say y plus z plus maybe w. Right. So here, let's say y holds the value of 2, z holds the value of 5, w holds the value of 4, right? And x holds the value of let's say 5 itself, right? So what will happen here is x times, so the value of x is 5, right? So 5 times y, the value of y is 2, plus the value of z is 5, plus the value of w is 4, right? So if I multiply this constant with some of these numbers, so this gets distributed to each of these individual numbers, right? So basically mean 5 into 2 plus this 5 gets multiplied with 5 here, 5 times 5 plus this 5 also gets multiplied with 4, right? So 5 times 4. Now you can calculate the total output. 5 into 2 is 10, right? 5 into 5 is 25, and 5 into 4 is 20, right? So 10 plus 25 is 35, and 35 plus 20 is 55, right? So this is basically the distributive property, which says if you multiply a constant with a sum of numbers, it gets multiplied with each of the individual numbers that you're adding, right? So this is the distributive property. This is the final output. All right, this can be verified by using, let's say, if you calculate all of these, sum of all of these. So 5 plus 2 is 7, and 7 plus 4 is 11, right? So this is nothing but 5 times 11, right? And this is also 55. So you're getting the same results, right? These two results are same. This proves the distributive property of addition. All right. Now, moving ahead. All right, guys, please give me a moment. Right. So these are the 4 properties of addition. Right. Additive property basically says if you add 0 to any number, you will get the output as the number itself. Right. So these are the properties of addition. Moving ahead with subtraction. Right. So subtraction is nothing but it is just an extension of addition only. Right. So instead of adding a positive number, we add a negative number. Right. So basically, if you say, let's say a minus b, so this can be written as a plus minus b. Right. I hope everyone understands that on the number line, let's say if this is 0, this is the center, right? This is the reference point here. If here we have 1, 2, 3, 4, and so on, right, on the positive x-axis. So in the negative x-axis, we'll have the negative numbers, minus 2, minus 3, right? Minus 4, and so on. And this is negative x direction, right? So subtraction is nothing but it's an extension of addition only, but here instead of adding a positive number, we are adding a negative number, right? So this is how subtraction is performed, right? So all the properties, those are held by addition, they are also held by subtraction. Right, which means all the 4 properties that we have discussed, right, which is the additive identity property, distributive property, associative property, and commutative property, all of these are completely and purely valid for, right, these are completely valid for subtraction as well. All right, now let's, all right, so these are just the properties you need to know, right, so that when a time comes where you need to use these properties, you can use them effortlessly. All right, now let's proceed ahead from subtraction to multiplication. Right, multiplication is also an extension to addition. Right, how it is an extension to addition? Right, how it is an extension to addition? Let's say when you multiply two numbers, how do you do that? Let's say if I say ask you to multiply 2 times maybe 4, right? So this is equivalent to, so 2 into 4 is 8, right? Everyone knows. But this is again equivalent to adding 4 2 times. Let's say I can add 4 2 times. Here also you get 8 as the output, right? This can also be written as adding 2 4 times, right? Adding 2 4 times. So here 2 plus 2 is 4, right? 4 plus 2 is 6, and 6 plus 2 is again 8. So the output is again 8, right? So multiplication is also an extension of addition, right? When you have to multiply one number with the other, it has to be very clear, right? That you are trying to add a particular number a certain number of times, right? So if I want to, let's say, generalize this, how this can be done is if I'm writing a times b, right? This is the multiplication symbol. If I'm writing a times b, this is nothing but we are adding a b times, right? Or in other words, you can also say that we are adding b a times, right? This is just to give you a clarity, right? These are just to give you, this is purely to give you to brush up your concepts, right? Everyone knows this. There's nothing I'm discussing that nobody knows, right? Multiplication, addition, you do on daily basis, right? In your day-to-day life, right? So this is nothing but it is the multiplication is repeated addition, right? It's repeated addition. This is how it's done, right? Again, we have certain properties for multiplication, right? The properties for multiplication, since it's an extension to addition, right? Since it's an extension to addition, all the properties of addition are equally valid for multiplication as well. For example, let's say the first property that we discussed, right? So the properties of multiplication, the first property of addition that we discussed, right, which is commutative property. Right? Commutative property basically says in addition, a plus b is equal to b plus a, right? In the similar way, in multiplication, a times b is equal to b times a, right? The second property is the associative property. Associative property says the order of the number does not matter, right? If you write, let's say in terms of addition, if you do a plus b plus c, right? So if you add a plus b first and then add c to this, or if you add b plus c first and then add a to the result of b plus c, the output or the final result will be unaffected. In a similar way, when you multiply a times b times c, right? So if you multiply b and c first, and then you multiply a to the result of b and c, this is equally valid to when you multiply a with b, and then you can finally multiply c, right? So this is basically the associative property. Right? In the similar way, we have distributive property. Right? So the distributive property of addition and subtraction are exactly same, right? Which says that if you're trying to multiply a constant with a sum of numbers, it equally gets distributed, which is a times b plus a times c. Right? Next, we have the identity property. This is an addition to the list of properties multiplication has. Identity property says if you multiply any number with 1, you're going to get the same result as output, be it, let's say, be it 1, right? Will be b itself. And finally, we have the last property, which is the zero property. Zero property says if you multiply any number with 0, you'll end up getting 0 only, right? No matter how big or small this number is. If you multiply this number with 0, you'll end up getting 0 itself. Right. So guys, the session is being broadcasted very fine from my end. There are absolutely no audio or video related issues. Right. So those were complaining about the voice being breaking up. This has already been confirmed, right? So my voice is not breaking. Please check your internet connectivity. Right. The session is being broadcasted very fine from my end. All right. So working as a data scientist, you need to know these concepts. Right? These are just basic concepts. Every kid of, let's say, 5th, 6th standard knows all of these formulas. Right? These are not formulas basically. These are properties of addition, subtraction, and multiplication, followed by division as well. Right. Now moving ahead with talking about the division. Let's move ahead discussing about the division. Right. So division is nothing but you divide one number by another. Right. So it's an arithmetic operation again that combines, let's say, two or more numbers. Right. And division in, let's say, simple terms can be understood like this. Let's say if you're dividing a with b. So here, what we are doing is we are basically splitting a into b number of equal groups. Right. B number of equal groups. right? What does this basically mean? Let's take an example, right? So well, let's say I'm dividing maybe 10 with 2, right? So what this says is you take this 10, right? Take this 10 and split this 10 into, right, into b number of groups, which is you simply split this 10 into 2 equal groups. All right. So this is the overall, let's say, intuition of division, right? We will divide 10 into 2 equal groups. So dividing 10 into 2 equal groups would be 5, right? These values are equal and these are 2 in numbers, right? So this is the basic intuition of division, how your 10 will be divided by 2, right? So you'll get 5 as the output, right? Because since they are equal, hence if you give output a single number only, that will also help, right? So 10 divided by 2, you'll end up getting 5 as the output. All right. So this is how division is performed, and this is basically the intuition of division. And when a division is performed, there are, let's say, various parameters or, let's say, parts of division. And what are these parts? Let's discuss about the parts of division. Right. So the parts of division is, let's say, when you write 10 divided by 2, right? When you write 10 divided by 2, what exactly is happening is this is how it's represented, where you are basically like this, right? So here, what will happen is we'll simply 2 will try and calculate any value that is equal to or less than the value that we have here, right? So let's try and calculate. So 2 into 1 is 2, right? 2 into 2 is 4, 2 into 3 is 6. All of these values are less than the given value, right? So we'll take the maximum value which is less than this, right? So 2 into 4 is 8, and 2 into 5 is 10, right? So although we got a value which is equal to the value that we are trying to divide, right? So here we'll take 5, so 2 into 5 times will be 10, and then we'll subtract both of these values to get what is being left out, right? So nothing is left out here, so that is absolutely not a problem, right? So there are basically a few parts of division, right? And let's name them one by one. So the parts of division are, this is the first part, right? This is the second part, this is the third part, and this is the fourth part. These are the 4 parts of division, right? This particular dividend is basically the value which you are trying to divide, right? This 2 here is called as divisor. Divisor is the value. Divisor is the value that you are trying to split your dividend into, the number of parts you are trying to split your division into. Guys, I hope my voice is better now. I've switched my network, right? I can see of you are complaining about the voice being breaking continuously, right? I hope this is better now, right? You can simply raise your hands to confirm if my voice is not breaking, right? If it's breaking, do let me know in the chat section, right? Okay. All right. All right. So let's proceed ahead. I'll just give you this walkover of division again, right? So in division, you have basically 4 parts. First is the dividend. Dividend is the original number that you're trying to split into, right? And you'll have to split it into any given number of groups, right? So the given number of groups that you're trying to split your dividend into is called divisor. All right. Now, the value that you get by multiplying, or when you're, let's say, multiplying the numbers, and the value that you get is basically the quotient, right? And whatever is left out is the remainder, right? So these are basically the 4 parts of division, right? I hope everyone knows this, and you can regain, or let's say you can achieve your dividend again. And how your dividend can be achieved is you simply multiply your divisor with the quotient, right? And add the remainder to the result of this. Add the remainder. All right, so let's say my divisor is 2, right? Times the quotient is 5 plus the remainder is 0, right? So 5 times 2 is 10 plus 0 is 10 itself, right? So my dividend is 10, right? And eventually earlier as well, my dividend was 10. All right, so this is how basically it works. Now let's proceed ahead to the properties of division. Right, so the properties of division here. Properties of division. First property is, it says if you divide 2 real numbers, right? If you're dividing one real number with another, it is not guaranteed that you'll end up getting an integer as the result. Right? It says that if you divide any 2 numbers, right, there is basically it's not necessary, right, that you'll end up getting an integer as output, right? So not necessary, I'll simply mention. So, sorry, it's not necessary to get integer as output. Right? You'll get real number as output. This will be your output. Right? I hope everyone knows the difference between real numbers and integers. Right? Integers are basically the whole numbers. Right? Integer is basically, let's say if you divide, for example, right? So for example, let's say when I'm dividing 25 by 5. right? So this basically is, it's returning me 0, right? So 0 is an integer, because it's not present in decimal places. But at the same time, let's say if I divide 20 by 6, right? If I divide 20 by 6, I'll end up getting 3.33, right? So here, this is not an integer. This is an integer, right? But this is not integer. This is not an integer. It's a real number. Real number are all the numbers that can be represented on a number line, right? This is what we call real numbers. All right. Now the second property is the second property. Second property says if you have a non-zero integer, right? Non-zero integer is any integer other than 0, right? If you have a non-zero integer, let's say I have some integer called x, right? This x is a non-zero integer. Is a non-zero integer, right? So it says, let's say if you divide this x with 1, you'll end up getting x itself, right? This is the second property. Right? Okay, yes, someone just mentioned correctly that here I'm writing the question, right? I'm not writing the remainder. So here this will be 5, right? Minus 2. All right, so this will be 5 here, right? So 5 is also an integer. Right? The second property is when you divide any number with 1, and the number should be non-zero integer, so you end up getting 1 itself. Sorry, the number itself. All right. So this is the second property. The third property is, let's say if again you have x, which is again a non-zero integer. Right? If x is a non-zero integer, if you divide this number by the same number, you'll end up getting 1. Right? Now, the fourth property is, let's say if x is 0, let's say x is equals to 0. If you divide this number with any number, right, with any non-zero number, if you divide this by any non-zero number, for example, let's divide this by y, right? So here y is a non-zero, all right? It's a non-zero number. It is not necessary to be an integer, right? You can divide the decimal values as well, right? So if you divide this with a non-zero number, you'll end up getting 0 only. For example, let's say if you divide 0 with 5, you'll end up getting 0. If you divide 0 with maybe 500 or 555, right, you'll end up getting 0. All right, so this is the fourth property. Moving ahead. Fourth property says, right, okay, so before proceeding ahead, let's say if y is just an extension of, just an extension of, let's say 4.2, right? Let it be 4.1. All right, so just an extension of this property. If in x divided by y, both x and y are equal to 0, in that case, 0 by 0 is not defined in mathematics, right? This is not defined, right? Usually in mathematics, we basically say that this division is not defined, right? You cannot divide 0 with 0, all right? Or even you cannot divide any number with 0, right? Dividing any number with 0 is also not defined, right? If you do this particular operation in any analytical tool, let's say be it Excel, Python, or anything, you'll get a 0 division error, right? You'll end up getting a 0 division error. 0 division error basically says you're trying to divide any number with 0, right? Which is not allowed because it is not defined. Now, the fifth property says, right? So the fifth property says, if let's say you have 3 variables, let's say x, y, and z, all right? You have 3 variables x, y, and z, and they are in such a way that x into y is equals to z, right? If x into y is equals to z, then you can derive any of these variables using the properties of division, which basically says you can end up getting y when you divide z with x, right? You can end up getting x when you divide z by y, right? So let's take an example for this. Let's say we have maybe, let's say x is 2, right? X is 2, y is 3, and z is 6, right? So if you multiply x into y, so 2 times 3 is 6, right? So you can get, let's say, you can get 3 by dividing 6 by 2, right? So if you divide 6 divided by 2, you'll end up getting 3. If you divide 6 divided by 3, you'll end up getting 2, right? So this is basically one of the properties of division. All right, so these are a few properties of division. Right, so you need to just basically understand these properties. Nobody's going to ask you about these properties, but yes, if you know these properties, this will basically help you a lot when you'll be working with mathematical operations in your machine learning or even in data analysis. All right. Okay, one of you is asking about the fifth property. Fifth property, I'll just give you a quick review. Right, fifth property says that if you have 3 non-zero integers, right, x, y, and z, these are non-zero integers, right, non-zero. If these are non-zero integers and they exhibit this particular property, when you multiply 2 numbers, you end up getting the third number, right? So basically, any of these numbers out of x and y can easily be derived by simply dividing the other number from the output, right? As an example, we took as 2, 3, and 6, right? So here, 2 times 3 is equals to 6, right? So basically, you can get 2 by dividing 6 by 3, and you can end up getting 3 by dividing 6 with 2. Right? So this is the fifth property of division. Right? So the first property is very straightforward. Right? The first property says if you divide any two numbers, let's say if you divide any two numbers, it is not necessary that you end up getting integer as the output. This is the first property. All right. Now moving ahead, let's say addition, subtraction, multiplication, and division. These are well and good, right? But what if, let's say, you have an expression that says, or basically that has all of these operations to be applied in one single equation, right? For example, let's say if you have an equation, something like, right? If you have an expression, something like, let's say, 36 divided by 6, right? Multiplied by 3 plus the square of 2, right? Minus 3 plus 5. If you have an equation, something like this, right? So which of these operations you're going to perform first, and which of these operations you're going to perform later, right? How this is decided, right? So this is decided using a rule called BODMAS. Right? This is decided using a rule called BODMAS. And what exactly is BODMAS? The B in BODMAS indicates bracket, right? O in BODMAS indicates order, right? This is also called off, or double F, right? Now, D in BODMAS represents division, right? M in BODMAS indicates multiplication, right? Moving ahead with A in BODMAS indicates addition, and finally S in BODMAS indicates subtraction. All right? And if all of these operations are to be performed in one single equation, then the order that you'll follow is from top to bottom. Right? This is the order that you're going to follow, which says the brackets will be solved first. Right? So anything inside the bracket, these are brackets. These are brackets, right? This has to be solved first. Then order functions. Order functions are basically wherever you have these kind of functions, where you have power, right? 2 raised to the power of 2. All right. Then division will be performed. This is the division. Then multiplication has to be performed, right? So basically, this is the multiplication. Right. Then addition. This is basically the addition. All right. And finally, subtraction. Right. So finally, you'll perform this particular subtraction. All right. So this is how you're going to use these operations to carry out the output of this particular equation. Right. So let's solve this so that you get an idea, right? How exactly is this feasible? Right. So what we'll do is, let me just rewrite this equation. This is 36 divided by 6 multiplied by 3 plus the square of 2 minus 3 plus 5 inside bracket. Right. So we have to solve the brackets first. So I'll simply write the rest of the equation as it is. So 36 divided by 6 multiplied by 3 plus the square of 2 minus the output of 3 plus 5 is 8. Right. So I'll write the output of this. I've solved the brackets. Next, I have to solve the order. Right. So I'll write the rest of the equation as it is. This is 36 divided by 6 multiplied by 3 plus, right? The output of square of 2 is 2 times 2. Right. So this is 4 minus 8. Next, I have to perform the division. Right. So this is the division that I'm going to perform next. So 6 divided by 6 is 6 multiplied by 3, added 4 to this and subtracted 8 from it. Next, I have to perform multiplication. Right. So this is the multiplication that I'm going to perform. 6 times 3 is 18 plus 4 minus 8. Next, I have to perform the addition. This is the addition. So 18 plus 4 is 22 minus 8. Right. And finally, I have to perform the subtraction part, which is 22 minus 8 is 14. This is the final output. If you're performing this in any other order, you'll end up getting a wrong answer. Right. You'll end up getting some other value. Right. So for example, let's say this is the correct approach using BODMAS. Right. Let's say this is the right approach. Right. Let's take a wrong approach. Try to calculate the output. Right. So let's take red color. Now here, what I'll do is I'll use a completely different approach. Right. And this is wrong approach. How wrong approach? Let me just rewrite this. 36 divided by 6 multiplied by 3 plus the square of 2 minus 3 plus 5. Excuse me. All right. Now, let's say, all right. So just give me a moment, guys. All right. So guys, please give me a moment. I'm just restarting my tablet. Right. I'm just restarting my pen tablet. Give me a moment. We'll be resuming the session very soon. All right. Okay. So let's proceed ahead. I hope everyone is able to see my screen now. Right, so here what we are going to do is we're going to I'll just rewrite this equation, right? And I'm going to follow a wrong approach. And this is just to show you that if you don't follow the rules of mathematics, you'll end up getting completely wrong answers. And this can basically misguide your complete analysis, right? It can be misleading for you. All right, so let's say this is 36 divided by 6 multiplied by 3. And then we have square of 2 minus 3 plus 5, right? So, all right, so let's perform, let's calculate the output of this first. So this is 6 times 3 is 18, right? And we'll write the rest of the equation as it is. All right, now, let's get the output of this. So, okay, so this is 5 here. Right, so 3 plus 5 is 8. We'll write the rest of the equation as it is. So square of 2 plus 36 times, so 36 divided by 18. Right, so now let's calculate the output of this. Right, so 36 divided by 18 is 2. Right, plus square of 2 minus 8. Let's calculate the output of this. All right, so the output of this is 2 plus 4 minus 8. Right, if you perform addition, 2 plus 4 is 6 minus 8. So this is negative of 2. Right, you can see if you perform in any other order, you're going to get a wrong answer. Right, so you have to be very precise when you have to calculate or when you have to perform more than one type of operation into one single equation. Right. So yes, this is the bond mass. Let's discuss about the power functions. I hope this part is clear to everyone. Right. Let's discuss about the power functions. Right. So what is basically the power function? It is represented like this: a raised to the power of b. Right. So a raised to the power of b basically says you have to multiply a b number of times b times. Right. What does this basically mean? You have to simply multiply a b times a into a into a into a like this and so on. Right. And this should be b times. This is exactly what power function says. Right. And this is exactly what it does. Let's take an example for better clarity of the same. Let's say if I'm writing here 5 raised to the power of 2. This basically says I have to multiply 5 2 times. Right. So this is nothing but 5 into 5, which is 25. Right. Let's take another example. Let's say 2 raised to the power of 10. If I write it like this. Right. So what does this say? It says I have to multiply 2 10 times. Right? I have to multiply 2 10 times. This is nothing but 2 multiplied by 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 2 and so on 10 times. I have to do this 10 times, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So I've multiplied 2 10 number of times. Right? Now you can calculate the output, right? 2 into 2 is 4, right? 4 into 2 is 8, 8 into 2 is 16, 16 into 2 is 32, right? This is 16, right? 32 into 2 is 64, 64 into 2 is 128, 128 into 2 is 256, 256 into 2 is 512, and 512 into 2 is 1024. Right? So the output of 2 raised to the power of 10 is equals to 1024. Right? This is what power function does. Right? Now, in a raised to the power of b, both a and b can be any number, which means they belongs to a real number. Right? Real number is basically a number that can easily be represented on a number line. Right? Let's say what if you have, and these could be real numbers are of course positive and negative both. Right? So for example, let's say if you have like this, 5 raised to the power of minus 2, something like this. Right? So this is nothing but you simply take this into the denominator, which is 5 raised to the power of 2. It is 1 by 5 raised to the power of 2. Right? Now you can easily calculate. This is 1 by 25, right? And 1 by 25, you can reduce it to the fraction and you'll easily be able to get the output. Right? So this is how. So this is basically 0.04. Right? So this is how you can do this. Multiplication of negative and negative is always positive in mathematics. If it is, for example, minus 5 raised to the power of 2, this is nothing but minus 5 being multiplied 3 times. Sorry, this is minus 5 multiplied 2 times. All right, 2 times. So here, basically, negative into negative is positive in mathematics. Right? Negative when multiplied with negative becomes positive. Right? And 5 into 5 is 25. So this is plus 25. Square of any number is a positive number. Right? Whenever the power is 2, whenever in a raised to the power of b, if a is 2, these are called square of numbers. Square of numbers. Right? And when b is 3, these are called cube of numbers. Those who are from mathematical background, you must be knowing this. Right? Otherwise, everyone has studied this in your school days. Right? In a raised to the power of b, if b is equals to 2, then these are called square of numbers. For example, this particular number is a square of minus 5. The square of minus 5. Right? At the same time, let's say if I write like this, 2 raised to the power of 3, this is nothing but this is cube of 3. Sorry, this is cube of 2. Right? This is cube of 2. Right? And 2 raised to the power of 3, what it indicates that I have to multiply 2 3 times. 2 into 2 into 2. Right? So 2 into 2 is 4. And 4 into 2 is 8. So the output is 8 here. This is the cube of 2. Right? 8 is the cube of 2. If someone asks you directly, let's say what is the square of 5? You simply multiply 5 with itself, right? And give the answer. Right? So this is how power functions are defined. Now, there's a special case in power functions. There's a special case in power function. The power functions are written as a raised to the power of b. Right? Here, if a is equals to 2.71, right? Or this is the exponential constant. This equation is then written as e raised to the power of b. Right? And this is a universal constant. Right? E raised to the power of b. These are called exponential functions. This is an exponential function. It is one of the most important functions that you'll use in your machine learning journey. Right? This is very important. Right? This is very important. You need to understand what is an exponential function. Right? It's e raised to the power of b. Right? But in let's say out of legacy and out of the kind of convention that is followed, exponential functions are written as e raised to the power of x. Right? You write x, b, c, any constant. Right? This is just a way of representation. Right? E raised to the power of x are your exponential functions. Right? And you'll use these functions almost everywhere. Right? These are one of the most important functions. You must have heard about the term exponential growth. Right? Maybe if you can raise your hands if you've heard about this term called exponential growth. Exponential growth. Have you heard about this term? You can simply raise your hands if you have heard about this term, that something is raising exponentially. Right? So what does this basically mean? Right? The graph of e raised to the power of x. Right? The graph of e raised to the power of x looks like this. Have a look. This is your y-axis. This is your x-axis. Right? When I'm plotting e raised to the power of x, how do I plot the graphs? I'll simply put the value of x as 0 because this is my origin. Right? I'll see what is the value of 0. So e raised to the power of 0 is 1. Any number raised to the power of 0 is 1. Right? So when x is 0, so when x is 0, y is 1. Right? So this will pass through this particular point, which is 1. Right? This is 0. Right? I'll put the value of x as 1. I'll try to calculate the output. This is 2.71. When the value of x is 1, this is x-axis, this is 1. The value of y is 2.71. So this is somewhere 2 here, this is 3 here. Right? So this value will be 2.71. Somewhere in between 2 and 3, I'll get this value. Right? Now, let's see if the value of x is 2. Right? So 2.71 raised to the power of, let's say 2. Right? This will be somewhere around 5 point something. Right? Let me calculate this. 2.71. Right? So this will be 7.34. Right? So this is 4, 5, let's say 6, 7, and this is 8. Right? So 7.34 will be somewhere between 3. Somewhere between here. Right? When your value of x is 2. Right? So this will pass through this particular data point as well. Right? So your plot will basically start from here. It will pass through this point and then it will pass through this point. Right? So this is how the graph of e raised to the power of x is traced. Right? When someone says exponential growth, this is how the growth is happening. Right? Or something is increasing exponentially. This is how it's increasing. Right? Very drastic. Right? So very drastic. If I trace this correctly like this, right? So this is how the graph of e raised to the power of x looks like. Right? Right? So this is exactly. Right? So if you're not getting this, that is absolutely not a problem. It's just an extension of this what I'm explaining. Right? It is just an extension. If you're not getting this, there is absolutely no problem. Right? Graphs has nothing to do with what we are learning. All right? So you can simply let's say go through this one more time. Right? If you're able to get this, that is completely okay. If you're not able to get it, that is also completely okay. Right? Because this has nothing to do with this. I'm just giving you an extension of some extra knowledge. Right? So this is how your exponential functions work. Right? So let's see the implementation now. Implementation of these functions in Excel. Right? Let's see the implementation in Excel. Give me a moment. I'll simply share my Excel sheet with you. Right? So this is, I hope everyone knows this is how your Excel sheet looks like. Right? I'll just zoom in a little. Right? So starting with, we learned about the addition. Right? Then we learned about subtraction. Then we learned about multiplication. Right? Then we learned about division. Then we learned about part mass. Right? Then we learned about the power functions. Right? Then we learned about the exponential functions. Let's see the implementation of all of these in Excel. Right? All right. Let's see one by one. Right? So let's say if I have numbers. Let's start with the addition first. Right? So let's say I have a few numbers here. Let's take only 2 numbers. Let's have 2 and 6. Right? I want to perform an addition to these numbers. How can I do that? I can simply let's say any operation, or basically if you want output of any operation in Excel, it will start from equal to sign. This tells Excel, or Excel will basically understand that you want output of some operation. Right? So this will basically be, we can simply do like this, 2 plus 6, we'll get 8 as the output. The other way is by using the reference cells. Let's say the value is present in some other cell. I'll simply provide the address of that particular cell. Right? And how address of the particular cell can be provided. This is 2, it's present in D3. You simply have to select the cell where the value is present. Right? Followed by a plus sign and followed by another value. Let's say D4. Right? So it will simply add the output of D3 and D4. The values those are present in D3 and D4. If I press enter, again I'll end up getting 8. Right? So this is how it can be done. Right? You can simply have a look. Let's say you can directly provide the values like this. Simply add 2 plus 6. Right? This is done. You get 8. Or you can provide the address of the values. Right? These values are highlighted. The ones that is written is in blue color. Right? It's highlighted with blue. The cell is highlighted with blue, and the one that is written in red, the cell is highlighted with red. So what it is going to do is it is going to add the values that is present in both of these respective cells. Once I execute this, I'm getting 8. Right? So this is good for let's say if you have a very limited number of numbers. Otherwise, what if let's say you have more numbers like this? We have 2, 6. Let's take 10. Right? If I select all of these and extend it, it will simply create more series for me. Right? Now, let's say if I want to add all of these numbers. What in that case? So in that case, I have something called sum function. Sum function, what it does is it adds all the numbers in a range of cells. Right? You simply press tab to activate this. You have to pass numbers now. So the one way is you can select individual cells separated by a comma. Right? You let's say separated by a comma, like this. Right? You select every individual cell one by one. right? You do it like this, and you'll be able to add all of these numbers together. Otherwise, like this is the output, right? 242. It's adding all of these numbers, right? If you select all of these cells, you can clearly see, right? You can clearly see the sum is already written here in the top, in the bottom right corner, right? Let me just change the color of the pen. This is the sum that is already written. If you select all these cells, right? It also gives you the average of all these numbers. It also gives you the total count, how many cells are selected. So there are 11 cells are selected, and the values that these cells hold, the sum of these is 242, right? And that is exactly what we are doing here using this value, right? Using the sum function. Now, there's a better approach to do the same. Let's say this is the cell which I want the output. I'll again use the sum function only, right? But since I have all these cells present in a range, so I simply select the complete range, and this is how it's written, right? D3 colon D13. You simply have to select the cell. These will be taken by themselves. Right? If you press enter, again you'll end up getting the sum of all the numbers those are present in a range of cells. This is exactly what sum function says, right? Sum function will basically add all the numbers in a range of cells. All right. So if you want to activate this function, simply press tab in your keyboard. Press tab. Right. Once you press tab, this is how the function gets activated. Right. So once the function is activated, you can select the range of cells that you want to add. Say I want only last 3 or last 4 cells. Right. So it clearly says D10 to D13. Right. So D10 to D13, this is being highlighted. If I press enter, I'll end up getting the sum of these numbers, some of the numbers that I've selected. Right. So this way you can select the complete range of cells, or you can select basically a subset. This purely depends. All right. I've already mentioned this formula starts with equal to sign. Please use equal to. If you write some, let's say if you write some like this, right, nothing is going to happen. Nothing is going to happen. You have to write equal to first, then you have to use the name of the formula. Right. So this is how formulas are executed in Excel. All right. Now let's proceed ahead. Same goes with subtraction. Right. Subtraction, you do not have any formula that is already defined for subtraction. Right. And why is that? Because in subtraction, what we are doing is we are deducting one number from another. Right. Addition can be done for a range of values, right? I can add 5 numbers together, but I cannot subtract 5 numbers together. I have to subtract one by one. This operation is taking place one by one, right? Which is why you don't have any formula that is or any function that is defined for subtraction. Simply have to use equal to sign, and you have to select the cells manually. Let's say I want to subtract 6 from 14, right? So I simply do it like this, right? I have to subtract 6 from 14. I simply do it like this. I press enter. This is the output that I'm getting, right? There's no function that is defined, right? There's no function that is defined for subtraction. All right. Now let's move ahead discussing about multiplication. Right? So multiplication also works in a very similar way how addition and subtraction works. Let's say if you want to multiply 2 with 6, the multiplication symbol is this asterisk sign, the star symbol that you have in your keyboard. Right? Let's say I want to multiply 6 with 2. So these are the two cells I'm trying to multiply, and 6 into 2 is 12. So I press enter, this is the output that I'm getting. But multiplication is something that can be done for series of values. I can multiply 5 numbers altogether. Right? That's absolutely not a problem. So which is why for multiplication, I have a fixed function defined, and the name of the function is product. Right? Product function says it will multiply all the numbers given as argument. Given as argument basically means given as input. Right? So if I press tab, this function gets activated. I can select maybe 5 numbers, right? I'll get the product of these numbers. Right? So 2 into 6 into 10 into 40. This is the output that I'm going to get from the product function, which is 1680, right? 1680. Right? So there's a product function that is defined. And in product function also, all the arguments are separated by a comma. Then as soon as you activate the function, the argument that is highlighted, you have to put value against this argument. Let's say I want to multiply 2 with 5, right? So I'll simply write 2. And as soon as I put comma, this number 2 written in the square bracket gets highlighted, right? This gets highlighted. So I have to input the value for number 2, right? So which is 5. Let's say I want third number as well. So now number 3 is highlighted, right? Let's say I want maybe 4, right? So 2 into 5 into 4. All these numbers, you'll see one difference, right? And the difference is, let's say the difference is number 1, which is highlighted as of now, right? This number is not present inside square brackets. But number 2, number 3, 4, and 5, and so on, all these numbers are present inside square bracket. This basically says that whenever you are using product function, you have to input at least one number to give you the output. All other numbers are optional, right? You can put, you cannot put. These are optional. Let's say you cannot use a function without giving input, right? Which is why all these from number 2 onwards, these are highlighted or these are mentioned inside square bracket. Any argument that is mentioned inside square bracket is basically optional argument, right? It is not mandatory to input the value against it. But yes, the number 1 argument here, this is mandatory to input, right? If I press enter, I will be getting the output of this. Let's say if I use the product function, input nothing, right? I close this bracket, execute this. It says there's a problem with the formula. You're not using it in the correct format, right? So you have to take care of this. Let's say if I put 2, it will give me 2 as the output, right? Because nothing is being repeated, all right? Or nothing is being basically, no other number is mentioned, which basically is 2 is not multiplied with any number. So it will return me 2 itself, right? Even if I use the sum function, right? And I input only one number, maybe 2, right? So this will return me 2 only because I'm not providing any argument for further numbers. All right. So these are the addition, subtraction, and multiplication, and then finally we have division. Right. In division as well, we don't have any function defined. We have to do this manually. Like for example, if I want to divide 6 by 2, right? So this is the backslash symbol, right? So this is the this is the front slash symbol, right? That you have to use as the division operator. If I press enter, I'll get the result of 6 divided by 2, which is 3. Right. There's no function defined for division. Right. So this is how we are going to execute this. I hope everyone is able to understand. These are very basics, right? You can simply raise your hands if you are able to understand what we are discussing in the session today. All right, now let's proceed ahead with the example of BOD mass, right? The BOD mass that we were discussing, right? I'll just rewrite the bottom part. Right? The equation that we used was, let's say 36 divided by 6 multiplied by 3 plus the square of 2 minus bracket 3 plus 5. Right? So this is the equation. Now we are going to execute the output of this, or we are going to write this particular equation in Excel. So that Excel will calculate the output for us. Let's do it. Right. So here, I'll simply mention the equation as it is. This is 36, let's say divided by 6 multiplied by 3 and plus the square of 2. Right. So this is written as 2 minus inside bracket 3 plus 5. Right. So this is the equation I've written without, I've written without equal to symbol. So this will be written as it is. Right. It is just considered as a text. Now let's write it using the formulas. So 36, I have to divide this by 6 first. Right. Then I have to multiply this by 3. Then I have to add. Okay. So before we discuss this, let me discuss the power function because it will be used in this particular form. Right. So let's discuss the power function first. So how power function is used is it's written as 2 raised to the power of, let's say a raised to the power of b. Right. Like this. So this is basically how it's used. We already have power function defined. Right. So power function returns the result of a number raised to a power. Right. So it requires two inputs. First is the number, which is a, and a raised to the power of b. A is number and b is power. Right. So we'll simply mention. Right. So we'll simply mention, let's say I want to calculate 2 raised to the power of 3. Right. So I'll simply mention 2 as number and 3 as power. It will simply calculate 2 raised to the power of 3 and give me the output. Right. So this is how power function is used. You can use power function to calculate the output of any, let's say 2 raised to the power of 10. We did this, right? This came out to be 1024. So this is exactly what we are getting here, right? So we have functions defined for every complex operation that you want to perform, right? You already have functions defined. You just need to learn how to use those particular functions. All right. So I hope this power function is clear to everyone. You can simply raise your hands to confirm. Now, if any one of you is not able to understand the power function, you can let me know in the chat section what exactly you did not understand, right? I'll be walking you through. All right. So here I would like to give you a homework. Right. So this is your homework. You have to calculate. Right. So first is you have to calculate the square of all the numbers from 1 to 100. Right. Second is you have to calculate the cubes of all the numbers from 1 to 100 again. Right. One of the easiest way I can tell you is if you want to create the series of numbers, you simply write the numbers, at least 3 numbers. Right. Let's say I want from 1 to 100. Right. So I simply write 1, 2, and 3. Now, once I select these 3 cells, and if I go to the right bottom corner, you will see my cursor will change from cursor to this positive sign. Did you notice this? I'll repeat this again. My cursor will change from this cursor to positive sign here. Right. Now, you can simply click here and drag and drop like this. So rest of the numbers will be created automatically. Let's say you want up till 100, you can go up till 100. Right. So let's say up till 100. Right. So all these values have been filled out. The pattern is already recognized by Excel. Right. Pattern is already recognized by Excel. Let's say if I take a difference of numbers, right? If I take difference of numbers, I'll take here. Right. Let's say I'll put 1, 3, and 5. Right. There's a difference of 2 between every number. I'll simply select these 3. Excel will automatically identify this pattern and it will create rest of the series with a difference of 2 only. Right. All of these are like this. Right. So 1, 3, 5, 7, 9, 11, 13, 15, and so on. Right. If you start with 2, let's say you start with 2, you go to 4, you go to 6. Again, here the difference is 2, but these are even numbers. Right. Now, if you click here, drag and drop, all the even numbers will be created with the difference of 2. Right. If you let's say mention day here, right? Let's say Monday, you write Tuesday, right? You write Wednesday. Now, if you select all of these, the rest of the days, it will fill out automatically. Right. Like this. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Again, it will start from Monday, Tuesday, Wednesday, and so on. Right. If you take the difference, let's say if you take a difference of 1 day, right? So maybe let's say Monday, then we'll take Wednesday. Right. We'll skip Thursday, we'll take Friday. Right. So this pattern is also recognized by Excel. Right. It's recognizing the pattern and it's creating 1 day gap. So Monday, Wednesday, Friday, then Saturday is skipped, Sunday, Monday is skipped, Tuesday, Wednesday is skipped, Thursday, and so on. Right. Even you can mention dates here. Let's say you can mention date. Let's say, for example, today is 02/07/2023. This is the date, right? If I mention, let's say 3/7/2023, these are 2 dates. If I select these 2, the rest of the dates will easily be created because the pattern is recognized by Excel. All right. So this is how it's being done, right? Now you have to understand one thing, that the format of date is completely different in Excel. Right here, the format of date is the first number represents the month. Right, it's not representing the date; it's representing the month. You can change the format. You go to home page here, right? You see, it's already formatted as date. So you simply go down here, right? You can select, let's say, long form of date. Maybe if you want to see it like this, right? Long form of date, like this. Today's right. So, for example, this is 7th February 2023. It was Tuesday. If I double click here, all of these gets converted to long form of date. Right. So this is just a try and experiment. You can do this at your end, right? You'll have fun learning Excel. All right. So let me leave all of these as it is. So the agenda was to calculate the square and cube of these numbers. I'll insert a column here, right? Let's calculate the squares here. Let's insert one more column here and simply mention that here we are going to calculate the squares and here we are going to calculate the cubes. How the square can be calculated? I'll simply use the power function, right? This is the number that I want, right? And the power will be 2 only every time, right? I'll simply mention some cell, maybe this particular cell, right? Although no number is present here, so it's taken, but I'll simply mention 2 here, right? So this will always take 2. Right? If you see here, B5, A4, these 2 numbers are multiplied, right? Now you see one thing, as I move down, so B5 will change to B6 because I'm moving down, right? And A4 will change to A5, but A5 I don't want. I want only A4 every single time, right? So you'll see that here It is B6 and A5. These two cells are highlighted. This cell is correct, but I don't want to change A4. I want to change the value, but I want to select the value that is taken in A5 only. Sorry, A4 only. Right? I want this value. I don't want the value in A5. Right? Again, if I move one cell down, what will happen? Right? Here, B7 is selected correctly. Right? But it is selecting A6 because I'm moving one cell down. This will always happen when you use Excel. So what can be done is you can freeze this particular value or freeze this particular cell. How you can freeze? You can simply add a dollar sign before 4 and before A. Right? So this will freeze this value, freeze this cell. Every time you move down, this is not going to change. Right? Here also 2 is taken because we have frozen this particular cell. Every time this 2 will be taken because square of a number can be easily calculated by multiplying the number by itself. Right? So this is exactly what is happening here. If I move one more cell down, here also I'm getting 9, which is correct. 3 into 3 is 9. Right? It is again taking A4 only. Every time it is going to take A4. So what I'm going to do is I'll simply double click here and rest of the cells will be filled out. So these are the square of all the numbers of 100 that is calculated. Right? And all of them are completely correct. If you see any value, A4 is frozen and this is 98. Right? So this is how you can easily do this. Right? In a similar way, cubes can be calculated. Let's say I want 3. Right? In cube, I will multiply the numbers 3 times. Right? In cubes, I'll multiply the number 3 times. Right? So I'll simply mention 3 in some random cell and I'll use that particular cell every single time. I'll freeze that cell. Right? So how this can be done? I'll use the power function. Right? The number that I want is this is the number, right? Followed by this is the power, which is A5. Right? You can simply press F4 as well. This will freeze your cell. Right? So let's say if I press F4, it will freeze the cell. It will simply add dollar sign before A and before 5, right? Which is before the row number and before the column number. It will simply freeze the cell. So execute this, right? And once I double click here, all of the cubes are calculated and it is perfectly correct. There is absolutely no problem. Right? All of these are perfectly correct. You can do this manually as well. Right? So let's check this. For example, 69. Let's multiply 69 2 times. So this will give us the square of numbers. So this value and this value is exactly same. Right? At the same time, let's multiply 69 3 times. 69 into 69 into 69. We'll end up getting. So this is 328,509. Right? And this is also 328,509. Which is the cubes and squares are calculated correctly. You can check this for any random value. You'll get the correct output. All right. So this is how you can cross check your results. All right. So although this was your homework, I just demonstrated how this can be done with minimum efforts. Right? I hope everyone is able to understand this. Right? The power functions and how you can basically use the power of Excel to minimize your efforts. Right? You can simply raise your hands to confirm if you're able to understand the exponential functions and. All right, great. All right, guys. So, okay, let me just repeat this one more time. All right, so basically, see what happens is in power function, please focus. In power function, you require 2 inputs. The first input is number. Right? When I write a raised to the power of b, let me just write this. Right? When I write a raised to the power of b, here a is number, right, and b is the power. This is exactly what is required in the power function as input. All right, so let's see. Here, when I'm using the power function, the first input is required as number, right? So first you have to input a. Let's say I want to calculate 2 raised to the power of 4. Right? So the number is 2, and since 2 raised to the power of 4 is written as like 2 raised to the power of 4, right? So 4 will be the power. Right? If I execute this, I'll get 2 raised to the power of 4, which means I have to multiply 2 4 times to get the output. If you multiply 2 4 times, it is equal to 16. Right? If you execute this, you're getting 16 as the output. Right? So this is how power functions can easily be used. All right. So now, since I've given you this as homework, and I've already solved this, so what I'll do is let me insert a few cells here. Right? And now you have to calculate the 4th power. Right? 4th power, 5th power. Right? You calculate the 6th power, calculate the 7th power, calculate the 8th power. Right? Calculate the 8th power, calculate the 9th power. Right? And finally, calculate the 10th power of every number from 1 to 100. All right? So basically, you have to calculate 1 raised to the power of 4, 2 raised to the power of 4, 3 raised to the power of 4. This way, right? In the 5th power, you have to calculate 1 raised to the power of 5, 2 raised to the power of 5, up till 100. Right? So 100 raised to the power of 5. In a similar way, you calculate the 6th, 7th, 8th, 9th, and 10th power using the power function. All right? And finally, you have to calculate the exponential of these numbers. Right? So exponential of these numbers can easily be calculated using the exponential function, right? Because let me just clear out. Right? So exponential of all of these numbers, right? So e raised to the power of 1, e raised to the power of 2, e raised to the power of 3, and so on. Right? So there's exponential function directly you can use, right? It is basically exp, right? It returns e raised to the power of a given number. Right? So you simply have to put a number, right? So the number is 1. So e raised to the power of 1 is calculated. This is the value of e. Right? I hope everyone remembers that in multiplication, I told you one of the properties of multiplication is if you multiply the number with 1, you'll get the number itself. So this is the number, which is e, right? So this is the number, and it is a universal constant. Right? So once you are able to find this on one cell, simply go to this top right corner, right? Your cursor will change from the normal cursor to this plus sign, right? And double click here, so all of your cells will be filled out automatically. This is called flash fill, right? It is one of the properties or functionalities of Excel, right? If you double click here, all of these cells will be filled out until the last cell where value is present, right? If I add 101 here, right, these values will be filled out automatically. If I put 102 here, all these values will be filled out automatically. I don't have to insert anything extra. If I write 103, the values are filled out. This is the functionality of flash fill in Excel. Simply, let's say, go to home and you see this. Right? You can, let's say, you can basically search, right, about flash fill. Right? So this is the property of flash fill. What it actually does, you can read about flash fill in official documentation of Excel. All right? Let's say if you put 104, the cells where flash fill was used, these cells are the, let's say, they will be filled out automatically. Right? If I let's say select these 4 cells and go up till maybe 130, 150, the cells will be filled out. Right? These cells are filled out, and now what can be done is you can simply double click here. The rest of the cells are filled out. right? So this is how you can use the functionality of Flash fill like this, right? You simply click here on the last cell and double click on the right bottom corner. All right, so this is how this is filled out, right? So yes, this is how basically you have to calculate, right? So I'll just mention your homework here, and your homework is the third homework is you have to calculate the right. Simply calculate the powers from 1 to, let's say, 4th to 10th power, right? For all the numbers from 1 to 175, right? Do this until 175, right? Do this until 175, right? So this is your homework. And explanation function is very straightforward. You have to simply use exp, which is the name of the function itself. You have to mention the number, right? E raised to the power of what number, right? So this number is basically the power, not number. Right? So if I execute this is e raised to the power of 1. This is e raised to the power of 2 because B7 is taken, right? This is the value that is being taken. E raised to the power of 2. If you go to the next cell, this is e raised to the power of 3. B8 is taken, right? In B8, the value 3 is present. All right? Now, and just a general information, you don't have to submit this homework anywhere, right? In the next session, I'll discuss the solution of this homework in the initial 15 minutes, right? So don't worry, every homework that I'm giving you, I'll discuss the solution of the same in the live session itself, right? So that every one of you is on the same page before we proceed with the next topic, right? So let's move ahead and let's go with the BODMAS. Right, so I'll just rewrite that particular equation. And that equation is, this is 36 divided by 6 multiplied by 3. Right, let me see. Okay, so this is plus square of 2 minus 3 plus 5. All right, so this is not clear. This is 3 plus 5. Right, so this is 3 plus 5. This is the equation. Right, so let's see how we can write this in Excel. I'll simply write in simple terms first. This is 36 divided by 6 multiplied by 3, and then the square of 2 is added, right? Minus inside bracket 3 plus 5. We'll close the bracket. This is the equation, right? Let's write this in very layman's term. All right, so I'll simply use equal to because I'm going to use a particular operation out of which I want the output or the result, right? So here I'll start with 36 divided by 6. This is multiplied by 3, and then plus. I have to use the power function, right? So I'll be using the power function here. Here the number and the power both are 2. I'll close this bracket, put a minus sign, I'll open the bracket again, 3 plus 5. Right, so this is how it's written. Right, so if there are more than one brackets present in an equation, you have to find the output of those brackets first, right? So if I execute this, answer to this is 14. Right, let's copy this and paste it in the below cell. Right, so here what I'm going to do is I'm going to eliminate all of these and use the functions of Excel, like how I've used the power function, right? Here I'll eliminate this operation and use the sum function. Then I'll eliminate this plus sign and use the sum function. Then I'll eliminate this multiplication sign and I'll use the product function. Let's see how this can be done. So the first thing that I'm doing here is I'm using the sum function. Since I want to add 3 and 5, I'll be using the sum function, right? And in the sum function, I'll simply remove this plus sign, replace it with comma, right? Let's see if I'm getting the same output or have I done some mistake. If I execute this, I'm getting 14 as the output, right? It is the same output that I'm getting using the functions of Excel, right? Let's edit this further. All right, now this is the multiplication sign that I want to remove by using the product function. How this can be done is I'll simply look what are the left and right side of the multiplication so that I can replace this asterisk sign or the multiplication sign and you replace it with product function. So this is the first part, or this is the part that is present towards right of multiplication, and 36 divided by 6 collectively is present on the left hand side of multiplication sign. So what I'll do is I'll simply click here, use the product function, right? This is the product function that I've initiated. I'll close this bracket here because this is until the product function is to be applied. And now I'll replace this multiplication sign with a comma. Let's see if I'm getting the correct output or have I done some mistake. If I execute this, I'm getting 14 as the output, right? Which is same as we were getting in the raw form of equation, right? Now let's edit this further. You see this plus sign here, right? Look at what is present on the right and what is present on the left, right? So on the left, this complete product function is present, right? And on the right, this part is present, which is collection of power and some function together, right? So what I'll do is I'll start my sum function here, right? It will start here, it will end here at the end, right? And I'll replace this plus sign with a comma, right? These are the two numbers that I'm trying to add. This is my first number, right? I'll just highlight this, right? This part is my first number, right? You can see the number 1 is already highlighted, right? And this is my second number. You see, number 2 is already highlighted, right? If I execute this, I'm getting 14 as the output, right? And this has been done because, let's say, for minus or for subtraction, there's no inbuilt function that is defined, okay, right? And for division as well, there's no inbuilt function is defined. All right. So this is how this is to be done. And we have basically converted this form of the equation to this form of equation where we've replaced all the signs using the functions of Excel. All right. So yes, that was all for today, guys. I hope everyone is able to follow what we are discussing. All right. So Google Sheet and MS Excel both are same, right? Just one of them is an online version, and this application of Microsoft Excel is just another option, right? The thing is, there are a lot of limitations with Google Sheet, right? So it is always advised to purchase an Office or Microsoft Office, right? Please purchase Microsoft Office if you want to work with Excel flawlessly. Right. So yes, guys, that was all for today's session. And as usual, I'll be waiting for let's say 5 more minutes. If any one of you have any doubts, if anyone question is let's say unanswered, you're free to ask in your chat section. Right. And if anyone wants to leave, you're free to leave. We're not going to discuss anything new now. Right. So the last equation, this is the equation that we have solved latest, right? So this is basically we solved this particular equation on whiteboard using the general approach of mathematics, and we have directly mentioned this inside the uh, as an operation, right, in Excel. And then we have replaced this with the functions of Excel here, right? So this is basically, see, it's always advised to go through the recording of the session, right? Always go through recording of the session at least 2 times. Most of your things will be clear, right? It's not always, this will not be the scenario that you'll get what is being taught in the live session in the first go, right? Machine learning and machine learning concepts, right? They are a little complex. They're not tough. They are a little complex, right? You have to use your logic and common sense at every stage of learning phase, right? You'll get everything very clearly, very easily. Right? So what type of function you have to use in what area, you'll get to know as we proceed ahead with the discussions, right? Just simply practice what functions we are already discussing in the live sessions, right? So yes, anything divided by itself is one, right? So I think this is very, this is very prominent to understand. If you let's say divide a number by itself, you'll end up getting one, right? So for example, 100 divided by 100 is one, right? 50 divided by 50 is one, right? So if you want to, if you want, let's say equations on what mass, I'll provide you on the on next weekend, right? I'll provide you the homework on next weekend, right? So that you can practice it. Meanwhile, try to grab the concepts that we are discussing here. Right. So, okay, one of you is asking about to explain the board mass once again. So, board mass is basically the list of operations that you want to perform, and board mass basically defines the order in which these operations are to be performed. Right. So, first you have to calculate the output of. Right. First, you have to basically calculate the output of the brackets, which means anything that is mentioned inside the bracket has to be calculated first, followed by the order function, or these are basically the power function. Right. Once you have calculated the power, you simply calculate the division, followed by multiplication, followed by addition, and finally the subtraction part is to be calculated. All right. So, this is the board mass function or board mass rule. All right, so submission of homework is not required. I'm mentioning this one more time. You don't have to submit your homework anywhere. All right, just I'll be giving you the homework or the questions as homework, and then I'll be providing you the solution of the same in the next session. Right, so don't worry about it. You'll get the solution for all the questions, and meanwhile, let's say you'll get around 5 days to work on your homework. All right, so you can self-evaluate yourself. Right. Right. For the notes I've already informed, it's always better to prepare notes by yourself, right? Because you need to know what needs to be mentioned in notes and how you can recall a particular concept. All right, for the date and day that is coming in Excel, you simply have to change the formatting of the cells, right? You can format your cells using any given numbers and uh, data, right? So it's absolutely not a problem. You simply go through the recording of the session one more time, you'll get this. All right, so if any one of you is not able to understand something or you missed out something during the session, you simply go through the recording of this particular session once, right? You'll of course be able to get this. Right, so 0 by 0 is not defined in mathematics, guys. It's not equal to 1, right? 0 divided by 0 is not defined in mathematics. Right, so dollar sign is basically used to freeze a particular cell, right? The dollar sign here is basically used to freeze a particular cell. Right here, we are freezing this particular cell, which means even if I go up, down, right, or left, the value from this cell will be taken only, right? You can explore more about freezing of a particular cell in Excel, what it actually does. All right. So I can see a few of you have started coming up mentioning that this function or that function is not present in your version of Excel, right? Which is why I've told you to upgrade your Excel to the latest version, right? Please upgrade your version, let's say Microsoft Excel to the latest version if you want to, let's say, get access to all the functions those are available in the latest version. All right. So yes, guys, I've answered everyone's query, right? So we are wrapping up the session for today, and thank you everyone for joining the session, and you have a good night.